When making racing games, one of the most tedious tasks is implementing opponents' AI. You know those crappy online racing games that only have time trial? That's partly because of how hard it is to write an AI that is actually shippable. So, if you don't want your games to be one of them, keep watching. Also, remember that these techniques could be used in both 2D and 3D games, but demonstration is in 2D for simplicity's sake. Let's start with what we expect from our AI. By the way, just to clarify, we are talking about non-player drivers in the game that work with an algorithm, not machine learning. So, first of all, we want an AI to be able to follow the racing line, aka the optimal path around the circuit. You should also be able to overtake other drivers that are slower, as well as possibly defending its position. You should reasonably avoid crashing and do all this while using the same inputs as the player, so no cheating. Here we have an example track on the screen. The racing line on it would look something like this. Or maybe not, I'm not a motorsport expert. The way we can make an AI follow this line is by using waypoints. A waypoint is just some coordinates on the game world. Let's assume that the star represents a waypoint that our car wants to go towards. How could we then write an algorithm that makes the car turn towards the star? Well, as with most things in computer science, we use math. Using this basic vector formula, we can determine the angle between where our car looks, vector B, and where it should go towards, vector A. You can simply find the vector A by taking the difference of locations of the car and the waypoint. And you can find the vector B by the rotation of the game object, that is your car. Actually, you probably don't even need to do this if you have a math library or a game engine. For example, in Unity, there is this method that will find the angle between two vectors for you. Then, we can just get the car to turn in the right direction until the angle reaches 0. And now that we made a waypoint, we can put a lot of them around the circuit on the racing line. Then, we code our car to follow the sequential waypoint when it reaches the current target waypoint. We can also give each waypoint a throttle value. This way, our car can slow down on the corners but floor it on the straights. Here's a waypoint system that is implemented with the given techniques on Unity for my next game. You can see it drives pretty smoothly, maybe even too smooth. Now, let's talk about overtaking. We want our car to detect if it is approaching a car slower than itself, so it can attempt an overtake. We simply do this by using rays. We cast a ray from the front of our car, which will detect if there are any other cars on its way. When it detects, this will trigger the overtake maneuver. We could also use this ray for crash avoidance. We simply check the distance to the car up front, and if it is too close, apply some brakes or cut the throttle. Going back to overtaking, we will again use waypoints to create alternative lines for overtaking, as we cannot go through the cars in front of us. And the car will prefer to take these lines when it detects a car up front instead of the racing line. And finally, you need to customize this framework to better suit your game. Really consider what would make this game better before deciding to implement these features. But it is always okay to implement them, just to try them out and see how it feels. Certain features might just not fit your game, even though they are great add-ons on paper. For example, defensive rating lines might be cool for simulation games, but they will be frustrating for arcade ones. Side-to-side crash avoidance might or might not be super necessary for your game, but I would definitely advise implementing some random mistakes to the AI drivers, as it really makes them come alive. I think I will be implementing them on my game as well.